Constructing generalizations. Objectives. At the end of this lesson, you will be able to first, compare and contrast generalization and concept. Second, trace the process of constructing generalizations. And third, design learning activities for constructing generalizations in a specific science topic. What are generalizations? Generalization is the concept that humans and other animals use past learning in present situation of learning if the conditions in the situation are regarded as similar. The learner uses generalized patterns, principles, and other similarities between past experiences and novel experiences to more efficiently navigate the world. For example, if a person has learned in the past that every time they eat an apple, their throat becomes itchy and swollen, they might assume they are allergic to all fruits. When this person is offered a banana to eat, they reject it upon assuming they are also allergic to it, through generalizing that all fruits cause the same reaction. Although this generalization about being allergic to all fruits based on experiences with one fruit could be correct in some cases, but it may not be correct in all. Generalizations are the most useful and powerful ideas in social studies because generalizations enable us to extend processes and events we experience. It develops from inferences we make through observations and provide more information than a concept. Generalizations differ from facts and concepts because they identify relationships between two or more concepts, construct explanations of cause and effect, and enable predictions of a future occurrence of the relationship stated in the generalization. Hence the quote by philosopher George Santayana, "Those who do not learn from history are doomed to repeat it."
So, generalization, it is the process of formulating general concepts by abstracting common properties of instances. It is reasoning from detailed facts to general principles. So, generalization is an essential component of the wider scientific process. General statement or concept obtained by inference from specific cases. So, generalization is the action of generalizing. However, the parts cannot be generalized into a whole until a common relation is established among all parts. So, every instance of a concept B is also an instance A. For example, the concept animal is generalization of the concept bird, since every bird is an animal, but not all animals are birds. Nagets ninyo? To make it short, a generalization is a statement that seems to be true in most situations or most people, but that may not be the completely in all cases. Now, para mas madali niyo magets, I will give you some example of generalization. So, cats are meaner than dogs. Dogs are smarter than cats, and nobody believes that Earth is flat.
Steps in constructing generalizations. Number 1. Exploration. Form a hypothesis. It is a specific, testable prediction about what you expect to happen in a study. For example, a study designed to look at the relationship between study habits and test anxiety might have a hypothesis that states, this study is designed to assess the hypothesis that students with better study habits will suffer less test anxiety. Unless your study is exploratory in nature. Your hypothesis should always explain what you expect to happen during the course of your experiment or research. Number 2. Lesson development. Gather information. Describes the process of acquiring knowledge. It is not the knowledge itself. When a portion of a story focuses on learning, it is the gathering of an education that is of concern, not the education that ultimately has been gathered. For example, your teacher gave you an assignment. It requires you to gather information. You may often do some reading for non-research essays to help you develop your thinking, hone your ideas, or find appropriate quotation, fact, or background information.
Number 3. Expansion. Determine how wide generalization can be applied. In everyday language, a generalization is defined as a broad statement or an idea that is applied to a group of people or things. Example: every salesman lies to make more money and to sell.
How to encourage kids to make generalization in science. Generalizations force kids to zero in on scientific concepts. For those kids that has a higher level thinking, give your science activities a twist. Begin with a conceptual questions. After that, present a science activity. Then ask kids to make a generalization. When you use this strategy, kids discover scientific concepts themselves. Just like this example of a teaching-learning scenario on constructing generalization. Miss Needs is teaching about light. She asks what kinds of materials are transparent, translucent, and opaque. Then she explains the terms. Each lab group receives flashlight and various materials. Miss Need shows them how to shine the flashlight toward the materials against a wall. Kids experiment with the materials. They write their observation on a lab sheet. Next, they discuss which types of materials fit each category. Finally, they make generalization to answer Miss Need's question. Students in one lab group write, transparent materials are clear. Translucent materials are partially clear. Opaque materials are colored and not clear at all. To wrap up the activity, Miss Need asks each group to share. Finally, the class collaborates to write shared generalizations. Their teacher hangs their findings on the wall. After that activity, Miss Need helps her pupils develop their ability to generalize. In the beginning, she asks, "What does all of this mean?" The class discusses findings as a whole group, so that the ideas of the students flow freely. Miss Needs guides them toward a conclusion. After that, Miss Needs switches her question to, what can we conclude and what conclusion can we draw? Asking this question helps students understand the language of science. In time, Miss Needs students are able to draw conclusion on their own. Asking kids to make generalizations forces them to think. Don't explain the concept. Instead, ask them, what can we conclude, so that the students will be well on their way to becoming lab scientists. Hi, I'm Rhea Dangasi.
My name is Hanimi Bitachi Clarabal.
I'm Amna Kotoldad Tom.
And I am Raysan Lambino. And we are the Team Big Dippers.